So I'm going to quickly go through the housekeeping, okay, because I've done this in another one. I've welcomed each one of you. Email me normally quickly. When things are not really doing good, quickly email me and then I can attend to you. Okay. So I want to start by telling you a little bit about management science. Management science is also known as operations research. It's a scientific approach to decision making. It's a quantitative approach that uses procedural analysis, algorithm, mathematical models, computational techniques to tackle complex real life situations. If the situations are not complex, you see that if situations are complex, people are not able to handle it well. Okay, so the algorithms act as tools for effective dealing with systematic problem solving and decision making analysis. For example, how do you decide ahead of time in the presence of uncertainties what to produce, how much to charge, how much profits to generate? How do you assign workers, schedule a task for them, okay, so that you'll be able to now do scheduling? How can you reduce queues in banks when students are registering, in voting time? How do you reduce the queues? There's something known as a queuing model. We shall look at that. Okay. So these are things that happen in real life businesses. And the last time we indicated that management science was born out of operational research or operations research. It was started in the Second World War, where the British and Americans military devised strategic means to win the war. They set up strategic moves, strategic models to win the war. And those methods, those strategies, after the war, became much more applied in engineering, manufacturing, health, business, telecom. And today, we study these things in management schools. And it's collated to be known as the management science or decision science, as we know today. So management science uses techniques, methodologies to be able to simplify complex things so that man can handle them. Some of the models or the techniques that management science deals with are different aspects of mathematical programming. So we shall do a lot of this. We shall do linear programming, duality, sensitivity analysis, transportation, assignment, transshipment models. Next semester, you'll be dealing with dynamic integer linear programming, goal programming, stochastic programming, some infinite conic programming, robust optimization. Welcome. Welcome. Okay. If you were telling your family members you're about to study operations, now is the time to prove yourself that you are about to study that. We shall look at deterministic models. We shall look at forecasted in this course, queuing models, network models, decision analysis, game theory. I'll teach you game theory. Okay. I will not be able to teach you simulation, Markov chain, probabilistic models. Some of them you study them next semester. So let's take a brief overview of some of these things. Linear programming we are going to do today, so I will not dig deeper into that. Queuing models, they help managers understand the best way to reduce queues. So what it means is that by the time you finish this course, you can be able to develop a model to reduce the queues that build up in your company or in any particular company. DEA is a data envelopment analysis, is a linear programming frontier methodology for assessing the relative efficiency and productivity change of firms that are similar in producing output using some input. We shall study this fully second semester. Sometimes people wonder whether management science, decision science, operational research, whether it is real, whether it can be applied in real market systems, and I guarantee you it can. It can. You can apply this thing in real life situations. And I'll be asking you some of this when I'm done. For example, the American airline, as we know them today, some years back, they were able to use forecasting and optimization, both of which we are going to study. They developed these models and use them to offer discounts and full fares in revenue management. In the process of doing that, by 1 year, they made $1 billion in incremental revenue. $1 billion just by adopting the method you are about to learn in this course. So who says it's not applied? And who says it is not, useful? There's a lot of money in there. China, they are well known when it comes to projects. They build a lot of big time projects. Okay. Now they wanted to handle their energy need because China is a very big country, over 1 billion people, and energy has been a concern. 1995, they used optimization, scheduling, and they were able to use that in their energy needs. And they saved $425 million. The cost, the methodology that they use is what you're about to learn in this course. South Africa in 1997, just some few years after the apartheid regime, they had a defense force, and they optimally redesigned the size of the shape of the defense force and the entire weaponry systems. They redesigned it, and they use optimization to do that. They saved $1.1 billion just using the technique you are about to study in this course. I know a particular bank myself, okay, in California. The bank had 33 branches, and they used data envelopment analysis, which is one of the techniques you'll be learning next semester. They use DEA to evaluate the relative efficiency and productivity of the branches of the bank. And in 1 year, they were able to save $6 million that were not identified using traditional financial and accounting ratios. And so it goes to show that beyond accounting ratios, something else can bring about, efficiency. Are these not telling information that shows that management science, operational research, decision science is very, very important to businesses, society, and individuals? But let's get even funny and look at a practical demonstration of management science in your everyday living. Let's assume that you want to go on a holiday in London. And normally you go and search for the cheapest flight. And so you use a sky scanner. Those of you traveling, you know it. Use a sky scanner, and the sky scanner has several algorithms. It's just like Google. Okay. Larry Page and his colleagues developed several algorithms in which, if you are able to say, what is phantasmagoria? Straight away, Google has an algorithm that will immediately search the entire world wide web and will fish out that and will give you multiples of areas where you can find the meaning of phantasmagoria. So the algorithms that have been set up in Skyscanner will find the cheapest flight for you, okay? The cheapest fare for you. And then you'll be able to now get it. But then you can also use another algorithm that will also schedule the flight crews and the aircraft that are used by the airline. You can see that. In fact, you can use the algorithm even helps you to be able to know which seat you want to sit on and whether that seat is occupied or is not occupied. All of this, you don't see it, but behind the scenes, things are happening. procedural analysis are happening. And if you were to go to London, and probably you need to rent a London cab, that will take you to your final destination. The price that you pay to the cab company, that black cab company, that price you pay is determined by a mathematical model. And that model is designed to maximize the profits or the revenue for the car rental company. Management science is at play. Management science is happening. And so who says that is not practical? But if you want to go into the real life like this, it's not going to be easy, because in real life, things are complex. So we use models in management science. Okay, so in management science, we'll be experimenting with models, because models will give you, will save time, because you are not dealing with a real artifact. The models will also help you to be able to cut down costs, and you save a lot of money. For example, if you have a model of an aeroplane, you can manipulate the model of the aeroplane to know whether it will have an accident, simulate it, bootstrap it, before you can deal with a real full-sized aeroplane. But if you want to deal with a real full-sized aeroplane straight away, it's not going to help. So in management science, we use models or develop models or enhance models. Ladies and gentlemen, you'll be building models, okay? For the first time in your life, you'll be building models. Let me ask you whether you remember these things in your secondary schools or A-levels, O-levels. Do you remember the days when you used to do simultaneous equation word problem? If you remember, just type yes for me. If you don't remember, just type no. Do you remember the days when you used to do with simultaneous equation word problem? Okay. Kofi is 5 years ago, older than his father, okay, or younger than his father. His father at the time was 60 years, but his father was 7 years older than, you know, those kind of things. That's it. That word problem, when you have that word problem, you have to convert it into a simple word model. Okay. A simple model. And that model can now be manipulated to find the answers to the whole thing. So models are very good. They help the managers identify profits and revenues and reduce the risks. You know. But if you give a wrong model, you're going to get a wrong solution. So your model has to be correct. If the model is wrong, the solution will be wrong. So we'll be dealing with models that are sensible models so that it can represent or mimic the real world. So we're going to look at one of the first techniques, and this technique is going to take us about 3 weeks to 1 month to complete it, because it's detailed. It's probably the most important technique in management science or operations research, and that is linear programming model. Linear program, or LP, is commonly used mathematical model designed to help managers decide ahead of time how to maximize their profits given the limited resources at hand. Based on the linear program, you can develop scheduling, can develop management, efficiency situation, media selection situation. In fact, you can handle financial planning, capital budgeting, which instrument of finance to invest in. You can handle how to shorten your distances you have to travel to carry things from one place to another, transportations. Linear programming can help be applied in all of these areas. And that is what we are going to be looking at. Where did it begin from? It started as a model. I'll look at the details, the components later. But it was first formalized and applied in economics by a man known as Kantorovich. This was in 1939, but it was not popular until George Danzig in 1947. During the war, Okay, of course, right after the war, during the war, that was when George Danzig developed the simplex method. That was the name of it. Okay, the simplex method was designed to be used as a way to deal with a linear programming problem. And these people have been well known to be great people in terms of Nobel Prize. So that is how it began, linear programming. It is attributable to George Danzig. What are the components of linear programming problem? Well, the components are here. First, you need to know a decision variable. A decision variable, listen carefully because this is critical. This is important. This is where you need to get it once. If you are going to go into any business, you got to make a decision on what you are going to produce or sell or bring out or showcase, or the services you want to produce. You want to be able to make that clear. You got to even decide the quantity of each one of those things you got to produce, you got to service, you got to give to people. And that is your main problem. That is it. So when that is your problem, that is the linear programming problem. If you're able to solve that problem, you're able to bring a solution to the problem. That solution to the problem is your decision variable. That's your decision variable. Let's take, for example, you want to be able to go into the production of shirts, shorts, pants. That's what you want to go into the production of. You got to know that, of course, there's going to be some materials. There are some materials you're going to use to do this production. But at the end of the day, you've got to make a decision on how many of the shorts, pants, and then shirts that you have to produce. So the decision variable has to do with the item that is coming out, the quantity of those items that is coming out. I'll combine the parameter and objectives together. And you will always have an objective. The objective will either to maximize or minimize the overall, output. Now, the overall comes from the decision variable multiplied by its price, its coefficient, or that item you're producing is per unit price. And your goal is to maximize that whatever outcome. So if it is shirts, shorts, pants, and you represent each one by X1, X2, X3, those are the items, but each item will cost something. So when you multiply the cost by the item, you are able to get a revenue. And of course, if you have other things to deal with, you're able to do some analysis and get profit out of it. That profit is the objective. And your goal of that is to maximize that parameter profit. But of course, it's not every time profit is maximized. What do you think we have to do to revenue? Type it there for me. We don't maximize, we maximize profit. What about revenue? Do we maximize max or minimize min? Revenue. Do we maximize it or minimize it? I'm checking those who are commenting with me a lot. Okay. Kweku, Richmond, and so you maximize that. You maximize revenue. What about cost? What do you do with cost? Cost, you minimize cost. You minimize. What about distance? What about the distance in kilometers traveled? Okay. The distance you have to travel. What do you do with the distance? You minimize the distance. What about the fare, the cost of the distance you got to travel? The cost of the distance you have to travel. What do you do with that? Do you maximize or minimize? You minimize. Okay. What about the audience in a theater? The audience in a theater. Okay. The audience you are bringing to a theater to come and watch. Do you maximize or minimize? Somebody is confused there. Somebody is confused. You do what to a theater audience? You maximize. You maximize. What about the returns on investment? The returns on an investment. What do you want to do with that? The returns on the investment. You maximize the ROI. Okay, you maximize it. You maximize it. So you see, during your readings, during your simultaneous equation problem, your job is to determine whether it's a maximization or it's a minimization, and of course, the decision variable. Now, the final thing is the constraints. I told you earlier that you cannot produce or service or product unless you have some materials, and these materials are not just there, they are limited in supply. So the last thing you have to deal with is the constraints, the limitations. And there are several of these resources that are constrained. Most resources are constrained. One of them is time. We are all limited by 8 hours a day work or 24 hours a day, alive. The labor force, you are not going to get all the people you want, the materials, the money, the resources needed to be able to do that. These resources are constrained, and you've got to now know how many combinations you're going to deal with to be able to come out with a right outcome. All right. So we're going to take these things one by one and make sense of them. We're going to explain it using a simple example, okay? And then that will help you to understand. But before that, you have to know the properties of a linear programming model. What do I mean by the properties? The properties are certain things that have to be there, more or less, for certain things to work. So they have to be there. They are one of the characteristics or features whenever you are undertaking a linear programming problem. And one of the first properties to recognize that there is one objective function. It is not multiple objectives, it's one objective. In next semester, you'll be dealing with multiple criteria decision making, which is known as goal programming. That one, there are multiple objectives. The second thing about a property, one of the features you will note about this linear program is that you can have more constraints or one constraint. So one of the constraints can be labor, capital, time, and all of that. There are also alternative courses of action. So it's not one course of action you got to deal with. There are several options, alternative courses of action. You will deal with proportionality. Okay? So proportionality means a percentage of this will lead to another percentage of that. So if you are to increase the labor by 20%, you expect a percentage of that 20% to reflect in the output, okay? Like constant returns to scale. There is additivity. You can add the variable. You can add x1 to x2 to x3. There's additivity there. There's also divisibility, and key, there is certainty. So when you say that I want to take 10 gallons of something, that 10 gallons, you are certain of that. Later on, when we deal with decision making with uncertainties, you see that all of these will change. So when you look at a Winston book, okay, you will get most of the information that we are looking at here. You see, I'm more interested in giving you an example because example is more efficacious than precept. But before we go into the examples, let me ask you, what have you learned so far?